Our next speaker is Dr. Do Hu. She's a PhD in animal breeding and the product manager at MGI, China. And she will showcase the developments of how in China genomic evaluations are performed. Do, are you here with me?
Yeah, thank you for the listening. My name is Do Hu. I come from MGI Tech, the Chinese company, and we are the sequencer company, and we have a sequencer and automation. And today's presentation's title is, you already see, is the genomic selection in China. And we provide a lot of molecular breeding solutions enabled by the DNBSEQ technology. And today's presentation, we just give some case study that we can show that in China. Can you move to the next slide? Yeah, when we talk about the livestock production, what we are talking about, it's not only about the genotyping or about something else. It's like a comprehensive work. So we need to think about like the animal breeding, animal genetics, animal nutrition, the environment, and the management. It's a lot of things. But what we can provide from our company, what we can provide for the breeders and the researchers. Next slide. We can provide a lot of things actually, just like we have the end-to-end solutions for the different functions. But today's presentation, due to the time limitation, I will focus on two parts. One is the genotyping method that we can use for the breeding, and another is the faster pathogen detection with our own technology. Next slide, please. So it's just like this one is quickly show that we need to know that the genome selection is really important for the livestock breeding. Like based on this one, based on the genomic selection, when we know the genotype of the offspring of the candidate, we can expect the breeding value just without the phenotyping data as previous. So we can short the selection cycle. And nowadays, the problem, what kind of technology for the genotyping we need to choose, and whether the genotyping technology can give the accurate results within the short time and with a really nice price. And that is the question to all the breeders and the researchers. So today's presentation will focus on this kind of the questions. Next slide, please. But when we talk about the genotyping technology, we need to know the origins of the genotyping method. It's just like in this technology is just like taking I need to say decades. In 2001, that my vision, just the first time to have this kind of launch this kind of idea that we can apply genome selection in the livestock breeding. And just based on these publications, that in 2007, the first microarray, the bovine high-density microarray launched. And in the following 15 years, I should say, that a lot of microarrays based on the different species and applied in the market, and more breeders and the researchers, they use the microarray to do the breeding, to do the research. But when we, as all of us know a lot of limitation for the microarray, and the speakers already mentioned, my previous speakers already mentioned this difference between the microarray and sequencing. And it's the same thing that we find it that from our researchers, like in 2019, that HEAS first launched that we need to have this 1,000 Wu genome project. Everyone knows this gene project. And this is the first time it's like to demonstrate that when we're using the sequence data plus the biological primary information, that we can predict the breeding value more accurate based on the sequencing data rather than the micro data, and especially for the multi-species genome selection. Next slide, please. So that we can see that for the market trend, we have a really clear trend from the microarray to the sequencing. So that is why I'm here to show some DNBSEQ technology, because all of our technology, all of our solutions are based on the sequence and not based on microarray. Next slide. And next slide, please. So For our MGI DNB-seq technology for the genotyping, we have the different solutions. It seems like different solution, but for us, it's just like this is the different library preparation kits. If that's the breeders or the researchers, they are interested owning like less than 5,000 SNPs. It's not like advised to use the whole genome sequencing to do because that will be not cheap enough. So we will use like the autoplex here. And what is the autoplex mean? It's just like the multiplex, or we said is the 2 steps PCR to do the genotyping. And we have this technology. And okay, you have more density markers want to do. And that moment that we can provide the liquid chip technology. And the liquid chip seems like the microarray. They always have chips, but that this is the sequence-based technology. And what is the liquid means? It's the genotyping by target sequencing. We do the target sequencing, but with the probe hybridization and in the liquid library preparation kits. So the probes were not solids attached on the microarray, but is flexible in the library preparation kit. When you want to change some SNPs you don't want to do for the next one, just order the new props and you will get the new arrays, new chips. You don't need to redesign and reproduce the microarray, just get the liquid chip. And later, when we reach like, I remember like for the bovine breeding that we have the 770,000 microarray in the market, because in some species we don't have enough research for that. So want to know the whole genome information to do the breeding or to do the research. At this moment, that the low pass, the low coverage whole genome sequencing is a really nice solution to do it. Because when you do the low coverage with the imputation technology, that you can get the same accuracy genotyping, you will get the same accuracy of the genotyping, but with the low price compared with the normal whole genome sequencing. Next slide. And why I talk about the DNB-seq now, just our DNB-seq is just like, we will see this cycle in the pictures. And this cycle means when we do the application, every time do the application is with the original template. So if there's some errors occurs for the next run, for the next application, these errors will not inside anymore. So based on the DNB-seq technology, we will have the live application BIOS. We will have the we will have the low index popping, and we will get really nice results when we compare with other chemistry. Next slide. So I'll talk about a lot of technology details, but now I just want to show some case that we already use in China and to share the story with all of you. Like first one is the liquid chip. The porcine, we have this first 50K porcine liquid chip in China, and we cooperate with the China Agricultural University with Professor Zhang's team. And for this liquid chip, they have more than 30,000 SNP. The markers are the same as the GeneSeq, the GGP50K porcine chips. So I think that is the popular chips in the agriculture market. We find that the 30,000 markers are the same, and the genotyping result based on these two methods, the consistence is more than 99%. So that means with the liquid chip, we will get nearly the same result as the microarray. And we have the flexibility rather than the microarray. If you don't want to use part of the SNPs in the chips, just change it and you will get the new one. And that is really easy for us because we don't need to open one production line and get a new products. Okay, next slide. Based on this technology, this liquid chip, we say is the genotyping by target sequencing, and our DNB-seq T7 sequencer. This is the sequencer already mentioned, to show in the slides that we already have several components that use our technology to provide the service to provide this breeding service. the sequence service for the customer in China. So, and we have this kind of list or a lot of commercial available liquid chip in the slides. That in the common species, we already have the commercial chips, and we are really welcome to cooperate with the breeders and the researchers to design the new liquid chip. And next slide. And we talk about a lot of things about the liquid chip. Now we go back to the low pass whole genome sequencing as well. Like many people will think about whether low pass, this low coverage whole genome sequencing can be applied in the production nuts. And this is the case that we need to show it. Yes, we can say yes. And this one is the published paper we already mentioned. It's the China Agricultural University and North Agricultural University cooperate with the Wins Company, and which is the biggest pig and the poultry production company in China. So we applied this low coverage whole genome sequencing in the Wins Company for the pig breeding. And it works well, really good. We do the average is 0.7. I remember it's average 0.7x coverage WGS. And we predict the breeding value. We find the accuracy for the for some trait increase 50% to 40%, depends on what kind of trait we are doing for the prediction. And next slide. And this one is what we do for the cattle breeding. We work with the Northwest Agriculture and the Forest University in China, and Professor Johnston do this one. We use the low coverage, low pass WGS first to construct the reference panel. This one is average is 13 or 30x coverage for reference panel, and in this project we compare with the accuracy among the 0.5x, 1x, 2x low pass whole WGS with the commercial microarrays, the 50K evolving microarray and 770K microarray, and we find that the accuracy between the low pass and the microarray is more than 99%. So that's to show that with this low pass coverage that we can build a really high quality reference panel, and we can get really nice accuracy for the genotyping results, and with extremely low coverage. That means we can use really low price to get the whole genome genotyping results. Next slide. And this one is the last application I need to show is the autoplex. We call it autoplex. And this one is the multiplex and the amplicon sequencing technology. And we show the cases for the fish breeding, because usually for the fish breeding, we don't need thousands or 10,000 or 100,000 SNPs, maybe less than 1,000 SNPs, that's enough. And this is the case that we cooperate with one team for the orange spotted grouper. And for this fish, they only need 700 markers that we can do the breeding. So we use this autoplex to do the 2 steps PCR, and we can get the results. And the SNP accuracy is more than 99.8%. So we really proud to just like to show these applications, all these solutions to all of you, to say that we have really reliable solutions for the genotyping. And all of this case that have the published paper, and someone are interested can ask me to provide it. So next one. We talk about a lot of breeding technology. And the first slide I already mentioned that today I will show something about the pathogen detection as well. Actually, for the pathogen detection, we don't need new instrument or new sequencer or new technology. We can use the autoplex, this multiplex platform to do the same thing. And this is the corporate project with the China Agricultural University. We designed one panel for the porcine pathogen, and we including the common 50 pathogens in one panel. So with these panels that we can easily detect the pathogens from the pig's feces or from the environment, and we can get the report directly. And this is really easy and quick method for the high throughput pathogen detection. And we already have the cooperation. We try to, we should say, we already have some cooperation with some company, because this is still under the test, so I will not show here. But I mean, this is like a convinced technology, and we have this published paper as well. Next slide. And the previous autoplex that can be designed for the pathogens we already know, but for the pathogens we don't know what we can do. We have this technology is the fast pathogen detection software with the metagenomics. And after we do the metagenomics library preparation, and we run it in the same sequencer, and we will get the result with FastQ result and run this pathogen detection software, and we will know what is it's exactly it is. Even we don't know what is that. So this software is really nice for the unknown pathogen detection situation. And here is just the list of the reference genome we already included in our data set. And if someone want to detect for the pathogen that are not listed in this system, just give us the reference panel and we can edit it for free in our database, and you can use it. Okay, and the next slide. So this is like the whole presentation for today. And is there any question that I'm very happy to answer? Thank you.
Do, thank you very much. That was quite interesting. Do we have questions from here? No, let me check the translation. No, so far, but I have a question. You mentioned two projects for pigs, the one for genomic relations and the second for pathogen detection. But you mentioned that they were made on commercial farms. I'm interested whether the government, the state, somehow supports such kind of projects, or are there solely the farm initiatives, and they fund it by themselves and initiate them by themselves? Are there any support from the state for such kind of innovations in the farming?
Actually, like for the Wings company, because this is the biggest company in China, the biggest pig production company in China. So they have a lot of like a research program with the government funding, but they have some program with their own funding as well. So for this project, it's the joint project between the university and the companies. So not from the government one, but because the normal they use the microarray to do the genotyping before, and now they just change their genotyping method, but their routine work still need the genotypes. And for the pathogen detection, because this one is from their initial use as well. It's not there's no limitation, because when you do the production, you need to detect for the pathogen regularly, not every day, but regularly. So they have this kind of needs. Yes. So even they don't use our technology, they need to do them by PCR or by qPCR, by any technology. But our solution, just like if they they can do one time, just run one time, but get more than 50 pathogen in one time, and with a lot of samples together. So this can save their human resource and money. So that is why they just come to us and to find some joint project.
Okay, thank you. And the other question I have for the cattle evaluations with the low pass, is it already implemented somewhere commercially, or was it just the research not implemented in somewhere in the practical field so far? And as well, if not, is it planned to be used on larger scales?
Actually, for the cattle breeding, we have commercial cattle liquid chip already. But I should say, to be honest, if it is for the dairy breeding, that the difference will be not too much, that we can use it directly. But if we use for the cattle for meat, like this breeding, we don't know whether it is suitable because that is based on the Chinese breeds and some of the public reference genome worldwide. So I'm not so sure that like in Russia, whether we have like the localized breeds, whether the difference between the local one and the world public one, whether they have a huge difference. If there's no huge difference, that commercial liquid chip can be used directly. If not, we need to do some slight change. But
Okay.
that is our advantage. We are so flexible.
Sounds great. Okay, thank you, Do, very much.
Yeah, thank you.